Hello everyone, I'm Sachin Sirohi and today topic I will discuss what is NLP and NLP with machine learning and deep learning. What is the concept behind the NLP and how we can embed the machine learning part and the deep learning part including with NLP. So let's see all these things one by one. I will explain the conceptual strategy. Those want to analyze the text with the help of some specified Python library. Now, neural machine translation introduction to RNN, LSTM, LSTM forward pass, LSTM backprop through time, application of LSTM, advanced LSTM. So these are some topics I will discuss in this video. Now the first topic is neural machine translation. So what is neural machine translation? So neural machine translation is a type of machine translation that relies upon neural network model based on the human brain, just like the human brain. So on in our brains, like some neurons, some analytical powers are there to build a statistical model with the end goal of translation. The essential advantage of NMT is that it gives a solitary system that can be prepared to unravel the source of target text. So we want to use our brain for those work we want to perform automated. Subsequently, it doesn't rely upon scientific system that are regular to other machine translation system, particularly SMT. So like first ESEB, that is a input sequence. Now I have ready a model. So I give the sentence into this format, then model will be ready the output like is it hot. So I use a symbol for to identify the input for the machine, but machine also understand behalf of the simple. So this kind of the things can be done by the neural machine translation. So firstly, we have to ready the model yt plus 1. Then what is the RNN and LSTM? So I will discuss what is the introduction to RNN and the LSTM. So RNN, recurrent neural network, remember to past and the decision. Are influenced by what it has learned from the past, like supervised learning and the unsupervised learning. So the machine learn from the past, supervised learning. Basic feed forwarded network remember thing too, but they remember thing they learned during training. The machine learned during the training. For example, if an image classifier learn what first look like during training and then uses that knowledge to classify thing in production. So RNN are called recurrent because they perform the same task for every element of a sequence. So this will recurrent neural network to repeat the same task every element, with the output being dependent on the previous computation. And you already know that they have a memory which captures information, what has been calculated so far. Like firstly, I'm just giving the input, then it will recurring the process like chat gpt. Like chat gpt, if I'm just giving some input, the chat gpt or some other ai give the output, then we are again click for the regenerate. So this is a perfect example of the rnn. Now lstm. So we have a data, now we have again ready a model. So what is the picture behind this? LSTM is an improved version of the regular RNN, which was designed to make it easy to capture long-term dependency in sequence data. A regular RNN function in such nearest to them which correspond to the short-term memory, while the network weight are influenced by the computation. That they place our entire long sequences, which correspond to long-term memory. Hence, RNN was redesigned so that it has an activation state. So when the recurring activity is there. Hence, the RNN was redesigned so that it has an activation state and that can also act as a weight and the preserve information over long distance. Hence, the name long term or long short term memory. So we want to work the capture long term dependency, not in the repetitive manner. So LSTM, long term dependency. So long term dependency forward pass. So now again we have created a model for some mathematical concept. So what is the picture behind to perform this particular pass? LSTM forward pass, as the name suggests, the forward pass, backward pass, LSTM are undirectional LSTM, which process the information in one direction either on the forward side or the back side. Where the bidirectional LSTM process the data on both sides, where the data on the both side. If I'm talking about the RNN, the data in of one side input data and then output. So all the LSTM type work on the basic structure. Updating the basic structure causes the difference between various LSTM. So all about forward pass, how the value forwarded to pass, all the checks, stack last in first out. So these are the forward pass, how the values on the both side. LSTM back prop through time. So again a model ready. So there is no need to ready manual all these things. The specified libraries are there to perform some analytical work or the some NLP process. So LSTM back propagation through time. We call it back propagation through time because we are repeating this process at each time step. If observed carefully, this is similar to the normal back propagation process. Ploys pictorially represent the LSTM cell. So now the pictorially I am representing this particular cell. The LSTM cell break propagation is different from RNN because in the time step during the back propagation, the values of the input gate, forget gate, and the output. So like logic gates are there, like input gate, output gate, forget gate. So these are the checks to use in this process to find out the timing. Now application of LSTM, where the LSTM is used. Robot control. So robotic control is a system that contribute to the movement of robot. This involves the mechanical aspect and programmable system that make it possible to control robot. So robotics could be controlled in various ways. which includes using manual control, wireless control, semi-automated, which is mix of fully automatic wireless control and fully automated, which is when it uses artificial intelligence to move on its own, but there could be option to make it manual control. So robot is a perfect example to control the robots, to control the whole process. Speech recognition is an interdisciplinary subfield of computer science and computational linguistics that develop methodologies and technologies that enable the recognition and translation of spoken language into text by computers with the main benefit of searchability. To enhance the searchability and to enhance the speech recognition, so it is the perfect example of this one, LSTM. Sign language translation. Sign language are language that use the visual manual modality to convey meaning. Sign languages are expressed through manual articulation in combination with non-manual element like sign language, like if I just arrow the sign, and not universal and are usually not mutual, intangible, although there are also similarity among different sign language. So the translation based on the sign, this is also part of the LSTM applications. Semantic parsing. Semantic parsing is the task of converting a natural language utterance to a logical form, a machine understandable representation of its meaning. Semantic parsing can thus be understood as extracting the precise meaning of an utterance. So application of semantic parsing include machine translation, question answering, ontology induction, automated reasoning. So these are the machine basically processing the questions and processing the answer and to automate yourself and to generate the result. Object code segmentation in computer vision. Object code segmentation is a special case of image segmentation, which is defined as jointly segmenting semantically similar object in multiple images or video frames. Advanced LSTM structures. So LSTM deal with both long-term memory and the short-term memory. For making the calculation simple and effective, it uses the concept of gates. Obviously, so the it is a concept of gates, logic gates. Like we have learned some in academic and or not XOR. So now similar we have a forget gate. The LTM goes to forget gate and it forget information that is not useful. Like someone is saying me forget. Whatever happened, forget. It is not useful for your brain. Learn gate event current input and STM are combined together so that necessary information that we have recently learned from the STM can be applied to the current learn. That means those processes are currently going on. Remembering gate or a remember gate. The ultimate information that we haven't forget and STM and event are combined together in remember gate and which work as updated LTM. Use gate. This gate also use the LTM, STM and event to predict the output of the following current event which work as an updated STM. So mainly these are the gates. The machine work behalf of these logic gates of the LSTM structures. You can see long short term memory. So those are not recall particular things in long time, short term memory, or you can say long short term memory. Short term memory is STM and the long term memory is LT. So these are the gate: forget, remember gate, learn gate, and the use gate. And these are the output. The figure shows the simplified architecture of the LSTM. Now the actual mathematical architecture of LSTM is represented using the following figure: LTM and STM, long term and the short term, and the cross, forget gate, remember, and all these gates. Then the value ready this one. Learn gate, they take event and previous short term memory STMT as input and keep only relevant information for prediction. Learn gate means keep only the those information are relevant. Forget gate, take previous long term memory as input and decides on which information should be kept and which to forget. So which information should be kept and which information should be forget. So like we take the example of the Twitter, and to analyze the text, those texts are not useful to forget and to learn them. Remember gate, combine prevent previous short term memory and current event to produce output, obviously. So those event or memory we want to remember. The use gate combine importance information from previous long-term memory and previous short-term memory to create STM for next and sell and produce output for the current event. So long-term and the short-term, and use them and to give the result of the next. So STM for next cell, that means produce the output of the current event. Encoder decoder attention. So what is the encoder and decoder attention useful in NLP? So encoder we know very well, like to encode something. The encoder is a kind of network and encode the obtain or extract the feature from the given input, like someone giving the input, then encode them. And the decode, obviously, the decoder is something that decode interpret the vector information, like those information provided this one. So then it will be decode, encode and the decode. So it is an encoder. So where how are you? So after like embedding this one, decode like go, I am good. So it will give the answer and the machine will again reply you, how are you? I'm asking the machine, how are you? It will like encode something. And the machine decode, I'm good. Attention mechanism, attention is the upgrade to the existing network of sequence model that address these limitations. The simple reason why it is called attention is because of its ability to obtain significance in the sequence. It is also the example like input sequence, encoder, RNN, repetitive to again repeat, and then decoder will be performed attention scores. Text summarization and text classifications. Text summarization is a very useful and important part of the natural language processing NLP. First, let us talk about what text summarization is. Suppose we have too many lines of text data in any form, such as form article or magazine or social media. We have time sketchy, so we want only a nutshell report of the text. So like for example, we have a number of article, we are combined them, the text generated, then split them and the vector, similarity of the matrix graph, and then so we are processing the data. So we are processing the text, combining, splitting, arranging. So there are two approach of the text summarization. First one is extractive approach and second one is a abstractive approach. So extractive approach using an extractive approach, we summarize our text on the basis of simple and the traditional algorithm. And if we are talking about the abstractive approach, an abstractive approach is more advanced. On the basis of time requirement, we exchange some sentences. What is text classification? So text classification is the process of categorizing the text into a group of words by using NLP. Text classification can automatically analyze text, then assign a set of predefined text. Like we have a document and classification system, art, business, culture, and entertainment. So we are just classifying the data, or we are just classifying the text. So there are mainly three text classification approach. First one is rule based system, second one is machine system, and third one is hybrid system. Now the next I want to discuss document clustering. So again we have a number of documents, then we are clustering like technology, sports, and the entertainment. So we are just creating a cluster, those values are similar. Document clustering. So document clustering is a method for finding structure within a collection of documents. So that is similar document. So we are just creating the cluster. Some clustering algorithms are there, KNN, K nearby, K means in Python. So we have some machine learning library, some data clustering library. So those values are similar. It will make the clusters. Attention mechanism. So the attention mechanism, in which area and in which text, in which data we should have to more attention. So attention mechanism is one of the recent advancement in deep learning, especially for natural language processing, tasks like machine translation, image captioning, dialogue generation, etc. So like comments say pa see to Jenny. So how was your day? So like if I'm just passing the particular uh, text, so how machine take all these things seriously? What text machine takes seriously? So the attention. Now questions answering engine. Like if I'm asking something, some questions processing, query formulation, answer type detection. So it will entirely process all these things. Document retrieval, relevant docs, passing retrieval, passenger. Then it will provide the answer. Questions answering engine. Question answering is a computer science discipline within the field of information retrieval and natural language processing NLP, which is concerned with building system that automatically answering questions possessed by human nature. Obvious tendency, like some user asking a question, the question classification then process, then it the data is available on the system, or it will process by the knowledge that it will provide the answer. So all these things I have completed regarding the topics of NLP and the methods